loud and clear.
You're
Can
reacting
you?
with your. You're reacting.
I believe you can hear me now.
Yes, we can hear you, sir.
I was trying to switch to the other browser so I can share the file, but there you guys are not hearing me. Let me bring the file here to this browser. Sorry, Victor. Victor, can you hear me? Victor, seems like. Can you guys see this? Okay. Hello, you guys can see the screen, right? You can see the file I'm sharing. All right. Um, so we are going to be talking about introduction to Solidity and Ethereum virtual machine. So once again, my name is Peter Victor. I have made this um, course very like self-explanatory. So I believe you can see clearly now. I've made it very self-explanatory. So I'm just going to be reading from here and then do my best to explain a little bit to you guys. So what is Solidity? Solidity is a statically typed object-oriented programming language specifically designed for writing smart contracts that run on Ethereum virtual machine. I just want to be sure you guys are seeing what I'm sharing because I'm using two different browsers. Okay. All right. Thank you. So, what do you mean by this is Solidity is a statically typed object-oriented programming language specifically designed for writing smart contracts that run on the Ethereum virtual machine (EVM). It was developed by Gavin Wood, Christian, it's Westner. Sorry, I can't pronounce that name. So the key point here is Solidity is specially designed for writing smart contracts that run on the EVM, Ethereum virtual machine. That's one of the key points to take here. and you can do further findings on the owners of Solidity, the people who developed the language or contributed to the language later on your own. The key point here is it is designed for smart contract. You cannot use it for back end, front end, or anything. Like guys, like this was coming from JavaScript. You know, JavaScript is designed for both back end and front end. You can use JavaScript for back end and front end, even Python. But for Solidity, Solidity is just purely for smart contracts. And what are the key characteristics of Solidity? They are contract-oriented language. Like I said, it is designed for smart contract writing, used primarily for Ethereum smart contract. Yeah, so far, yeah, Solidity was initially designed to write smart contract that run on the Ethereum blockchain, but I think now other chains are adopting it, Solidity. You can now write Solidity to use with other chains to pass from Ethereum. So it compiles to bytecode that runs on the EVM. The EVM doesn't understand the normal language, right? So it has to compile to bytecodes. I'll show you what bytecodes look in our next class when we start writing codes, or what bytecodes look like in our next class when we start writing code. So it is tactically
Sorry, sir.
variables. Variable
Can you
types
put
must
this
be
spelling
explicitly
in the
defined,
message?
like TypeScript. You have to define the variable type you want to use. Unlike JavaScript, where you can just define a variable without um, attributing it to any type, and then you can change it later. This Solidity is not like that. If you want to use a string, you must define it string. You must name it. You must let the compiler know that this is a string you're using. If you want to use an int or uint, unsigned integer, you must define it, clarify that this is an unsigned integer, uint, or integer, int. So you cannot just say let variable, example, let variable equals to 0. No, you must specify that this is an integer, a number. So it supports inheritance, library, and complex user-defined types. Yeah, we'll talk more about this when we start using libraries, like importing libraries from other contracts. So the Ethereum virtual machine, the EVM. Ethereum virtual machine is a Turing complete virtual machine that serves as a runtime environment for smart
Call
contracts
me
on the
Mr. Victor. Mr. Victor.
executes bytecode in a
Wait,
secure,
can
isolated
anyone hear me?
environment. Um, for JavaScript ES6, for people coming from JavaScript ES6, there is can't go this slide.
It seems like Mr. Victor cannot like my year or self.
So you can also see my screen, right? All right, nice. So for what was I saying? Okay, here are the key properties of EVM, the Ethereum virtual machine. It runs on every Ethereum node in the network, and it ensures deterministic execution. Same inputs always produce same output. For back then uh, when I was learning how to operate computer, it was garbage in, garbage out. Yeah, somebody's reading. Yeah, Richard, you have a question?
Hello, Sir Victor. Can you hear me? Hello,
Hello, Richard.
Sir Victor. Can you hear me? Hello, can you hear me?
Okay, you guys can speak. I'm listening.
Okay, so we can't see what you are reading. We can
Richard,
only see
like you're speaking, but I'm
the
not
screen.
hearing you.
Wow. Can you hear me now?
Hello. Okay.
Can you hear me?
Richard, I know you're speaking, but I can't hear you. I don't know what's wrong. My mic is actually on. It's not muted. Can you guys hear me? Okay, some people can hear. I'm not here. Yeah, okay, you can hear both of us, but I can't hear him. I can't hear Richard speaking. Oh, okay. Using two different screens. Can you see it now? But I don't know why I can't hear him. Maybe because I'm using. Let me switch to. Okay. Can you guys still hear me? Okay,
Yes,
Richard,
we can hear.
you okay? Okay, now I can hear you. Okay, I was using AirPods, so I just have to stop
Oh,
using
okay. All right, that's fine. So we can't see the slides. We can only see your Google Meet screen.
Oh, I understand now. I was using a different screen. Sorry. Can you guys see that?
Not yet.
No.
Up to now? Wow. How about now?
Not yet. You can't see your slides.
You can only see my slides. Okay,
We
that's
can't
it.
see your slides.
You can't see it or more. Let me stop using it. Let me stop sharing and share it.
Okay, that's fine.
How about now?
Yeah. I'm seeing the Meet dashboard.
How about the slides? You have them there.
No, I'm not seeing this slide, only the Meet dashboard.
Can you see it now? Guys. Can you guys see it now?
No, sir. We still can't see your slides. Okay, so Johnson has his hands raised. I don't know if he has a question.
Okay, Johnson, please go ahead. Hello, Johnson.
Johnson, can you go ahead with your
Yes,
question?
sir. Sir, please, we cannot see your screen. I don't know if it's from my end. We cannot see your screen. We
Yeah,
are
no,
not
no.
hearing you clearly.
I'm working on that. I'm working on that. Okay. What about now?
Yes, sir. You are not sharing your screen.
I'm sharing my screen. Okay. We can all see it now, right?
Yes, we can see your screen.
You can see the dashboard, right?
Yes,
Yeah, okay. So how about the I can do?
yes. It's live now. We can see.
All right, thank you.
Thank you very much.
You're welcome. So we are talking about the EVMs. You see, the EVM, the Ethereum virtual machine, is a Turing complete virtual machine that serves as a runtime environment for smart contracts on the Ethereum blockchain. It executes contracts, contract bytecode in a secure, isolated environment. I don't know how well to explain this, but I try to make it the definition self explanatory so you can understand. But I'll show you more examples of how this works when we start writing through. So the key properties of the EVM, it runs on every Ethereum node in the network, and it ensures deterministic execution, like same output. Whatever you put is what you get. Like I used to say, garbage in, garbage out. And it is completely isolated. People have no access to network, file system, or other processes. And then it uses gas as metering mechanisms to limit computation resources. In every transaction you carry out on the Ethereum on EVM, you have to pay gas fee, not the normal gas from amount of Ethereum in the smallest amount of the smallest, should I say, the smallest denomination of Ethereum. There are four denominations of Ethereum. There's what's the second one? There's Way and there's Way. The second one is in. And then here are the core concepts of the Ethereum virtual machine, the EVM. It's Turing completeness. The EVM is Turing complete, meaning it can perform any computation that a traditional computer can perform, given enough resources. And this allows for the complex logic and algorithms to be implemented within smart contracts, including loops, conditional statements, and recursive functions. I don't know if you guys are understanding. I like every explanation. I had to like inject every explanation inside instead of like listing them explaining. So if you guys are confused anyway, just hit me up. I'm not like looking at the screen, the dashboard screen. So I wouldn't know if you raise your hand. So you just unmute your mic and draw my attention if you have any question. So it is stack based. It has stack based architecture. EVM uses a stack based architecture. It has a 1024 element stack for operands. Operations pop values from the stack, perform computations, and then push results back. This simple execution model makes formal verification easier while reducing security risk. And let's talk about the memory model. The EVM has three distinct areas for data storage. There's the stack, which we just like the stack. There's the stack, temporary working memory mentioned above, and then there's the memory, volatile linear memory space that exists only during contract execution. And then there's the storage, which is persistent. It's a persistent key value stored where a persistent key value store where contract state is maintained between calls, and it's very expensive. It is the most expensive. Now, the bytecode execution. When a Solidity contract is compiled, it produces EVM bytecode. So the EVM cannot understand the normal language just right. So it has to compile it into a bytecode. A bytecode is a series of hexadecimal opcodes and operands. Each opcode represents a specific operation. I'll show you what a bytecode look like when we start writing code. I remember, like now, there's the arithmetic operations. the add, the multiply, the subtract, and it's and the logic operation, the and, the or, and others. And the stack manipulation, the push, the pop, and duplicate, and then the storage operation, the control flow, the environmental operations, the color, the call value, etc. You see all this when you start writing code on the using listen what they call this online IDE. So now let's all this you're like I'm reading now, I'm explaining this the key properties here. So here the deterministic operation, execution in details. Determinism is crucial for blockchain consensus. All nodes must reach the same state when executing transaction. Every EVM operation is precisely defined to produce identical results across all implementations. Random number generation isn't truly random, but derived from blockchain data. The timestamps are taken from block headers, ensuring all nodes use the same value. Execution is isolated from non-deterministic inputs like floating points operation. So now let's talk about the gas system mechanisms. The gas system serves multiple purposes: the economic security, prevents spam and denial of service attacks. Okay, the resource allocation. The resource allocation efficiently distributes computational resources. Halting problem solution resolves the Turing completeness issue by limiting computation. Now let's see how the gas works. Each operation has a fixed gas cost based on computational complexity. More complex operations cost more. Example, stop cost 20,000 plus gas. I add cost just three, that's three gas. So gas is paid upfront. Unused gas is refunded. Okay, it's if a transaction runs out of gas, changes are reverted, but the gas is still consumed. More like no refund of money after payment. But these two are different. This one and this one is different. Gas is paid up front. You pay for gas for any operation you want to execute. But then you can pay more if the execution doesn't cost that much. The remaining gas will be refunded, or the unused gas will be refunded. But here, if you are executing, like for example, you are trying to send a transaction and then you run out of gas, all the changes will be reverted. It will come back, but then the gas that have been consumed will not be refunded. I don't know if you guys get that. So here is the execution context. When a contract executes, it has access to the call data. I'll show you what call data is. Call data, input data for the function call. I'll show you what this is. Most of this you understand better when you start writing code. So the caller address, the address that is initiated, the address that initiated the transaction, and the call value, the amount of data sent with the transaction. Then the contract code, the byte code of the executing contract, and then the block information, timestamp, block number, difficulty, and all that. So cross-contract communication. Contracts can interact with other contracts, especially if these contracts are mostly public. Call, delegate call, static call, different types of calls that external contracts, calls external contracts. Yeah, I meant to say external here, not public. If most of the functions in that contract are external, other contracts can interact with them. I'll show you. I'll explain that to you in writing. Now I'll create a mechanism to deploy new contracts dynamically. These interactions form the basis for compatibility in Ethereum's DeFi ecosystem. It's very interactions here, like contracts interacting with other contracts. That's what's happening here. So the EVM isolation and security model. The strict isolation of the EVM provides critical security benefits. Contracts cannot access the file system of the nodes. Network access is limited to interactions with other contracts. No direct access to external APIs or data sources. Oracles are used instead. Memory of one contract execution is isolated from others. And this is why Ethereum is one of the chains with the most security. It has the best security. So transactions here are very expensive and they are not that fast, but it has the best security. So all external data must come through transactions. And for the security model, isolation and the security model. And then the EVM evolution and upgrades. The EVM has evolved through several upgrades, onset, basic stabilization, engineering issue, spurious dragon, gas cost adjustment, and security enhancement. So, like this very one, you can read more about this later. Like on your own, you can just do more research on it. I'll share this file, this attendee with you guys after this class. So EVM compatible blockchains. Here are the blockchains that are compatible with the Ethereum virtual machine. The EVM standard has been adopted by many blockchains in Ethereum. Like I said it earlier, it was originally designed for Ethereum virtual machine, but now other chains are adopting it, probably because of the security. So we have the Binance Smart Chain, we have Polygon, we have Avalanche chain, we have Optimism, Arbitrum, and there are many others. So this compatibility allows developers to deploy the same code across multiple chains with minimal changes, creating a rich ecosystem of interoperable blockchain networks. So here is the basic structure of a Solidity smart contract. First, in every Ethereum smart contract you want to write, you have to declare the license. And this is how you declare it. More like you're commenting it out. So SPDX license, license identifier, MIT, this is free license you can use to write your smart contract, Ethereum smart contract. And then we have the Pragma, the Solidity version. You have to choose the version you want to write. You have to specify it in a way that the compiler will understand particular version you're using. Here we are saying it should use 0.8.17 and anything above this. Anything above, any version above this, you can use. You can specify to use this lower. You can specify to use this one to a particular. When we start writing smart contract, I will explain more of that. You can specify like to use this very version from this version to a particular version. And you should stop there, not use anything above or above that one or below this very one. So to start with smart Solidity smart contracts, you have to declare contracts. This is how it knows you're writing a contract. You have to use this keyword contract. It's a reserved keyword for Solidity smart contracts. You have to declare contract and then the name of the contract. In this case, you're using my first contract. Here are state variables. I'm not going to write it today, but I just need this just to explain to you guys. Because after like looking at this, you may be able to write the Solidity smart contract yourself. Because I'm going to give assignment to like test the understanding. Okay.
Victor, someone has his hand.
Okay. All right.
Okay, so please can you brighten your screen a bit so that we can see your screen clearly?
Oh, okay. Set it up. That's okay.
Yes, sir.
Yes, it's fine.
More better.
Okay. Okay. So maybe after going through, you guys might be able to put a very, very tiny smart contract for us to check out tomorrow when we come on start, because we start like writing code tomorrow. I'll start explaining everything, what is each of these variable is, their names, and what they do, what they represent. Okay, for now we just like learn through this. These are state variables. Here it's been doing is 256. Taking public for other contract to see. Anybody can see this, it's public. And here's an address. All these are keywords for reserved for Solidity smart contract. Doing this an unsigned integer in 256. And then we are giving it value of my number. Yeah, sorry, my number with no value. So this by default is 0. And then this here an address. And then here we are emitting an event. Number change. Like anytime this number, my number change, it will emit an event to let you know that okay, my number has changed. And even the address, if the address changed, it will emit the event. We are declaring the event here. Sorry, we are not emitting it here. We are declaring it here. So here is a constructor. This constructor is only called once. That's when the smart contract is deployed. That's when this constructor is called. And then we are passing in owner, which is the address, message of sender. Whoever is sending the transaction, that's we are passing this address inside. And then we're also passing the number, my number, inside the constructor. And then here is a modifier. Modifiers are used to like customize should I say message or error message, or in not just error message, they are customized, used to customize variables to use. I'll show you where we are using this. This is a modifier called only owner. Here we are stating that only the owner can do a particular carry out a particular kind of task on this smart contract. If you are not the owner, it will emit, it will like show you an error, give an error message. Only the owner can call this function. Yeah. So this is a function. Declaring the function. To declare a function, the right thing for function. Unlike other programming language, here you can just take it. Very simple. Here you just declare function, and then the function is set my number, and then yep, this is a call data. I said something about call data earlier. This is a call data. It's a parameter. We are passing the parameter inside this function, and then we are making the function public. And we are passing this modifier inside here, saying that only the owner can call this function. And then once the function is called, we emit the event that we declared here, number change. We emit the event, we emit number change. Then we are passing it like the person who called the function. We knew it to pass it to emit the new number and never call the function, which is the owner of the contract, the sender. And now this is the state changing function. This one will cause gas. This very one is a state changing function. It will cause gas. It's a theta function. It will change the states of the contracts. And this one here is a getter function. It doesn't change the states. The reason we are using view, it only views. You're trying to get whatever number is this my number we declare here. Initially is 0. So after the caller calls this function, the number changes. And you're trying here to get a new function. When you call this function, you're getting the new number, we're getting the new value of my number. I don't know if you guys understand. You call the function to give you the new value of my number after I think this. Initially, if the caller doesn't call this function here, and then you call the function, you get the value of this. You get the value of this number, which is 0. You get 0. But once this function is called, and then you call the function, to give you a different number, a different value, a new value of my number. Whatever the caller inputs here is what this number inherits, and that is what this function will give you in the end. I hope you guys understand it. Like this very function, this is very contract to play around with it tomorrow to further explain to you. And then the fundamentals of data types in Solidity. I'm not even supposed to be like taking this today, but let's see. I have other works, but I have other works. I need to show you. Okay, let's just continue. Fundamentals of data types in Solidity, the value types, the boolean for almost every smart contract. Almost every computer language has this this type. You have this the boolean type, which is true or false. It is in JavaScript. We have it in Python. We have it in every smart contract, every programming language. And then the int and the unit. Define, which is the int, and the unsigned integers, which is the unit. The sign is from -1. Sorry, from negative. It has both negative and positive. While the unsigned is just from 0 to 0 and 1, 0 to. How do I say? There's no negative in the unsigned integer, but the sign is both negative and positive in the sign, in the int. But the unit has only positive numbers. And then we have the address, the Ethereum address, which is 20 bytes. Sorry, for integers, we have from 8 to 256 bytes. And the address, we have 20 bytes. And then we have the byte, the dynamic byte array. See more of that when we are writing the code. We have the fixed and unfixed 6 point numbers to see. And then the reference type is string. We have the array. We have the struct. Here you define structures. This is more like, should I compare to objects in smart? I think it's more like objects in JavaScript. And then we have the mapping. More of that when we start writing smart contracts. So we have gas and transaction execution. The gas is the unit to measure computational work in the Ethereum network. Every operation in the EVM costs a specific amount of gas. Users pay gas. Users pay for gas in ETH. There are two key components: gas price, the amount of ETH per unit of gas set by transaction sender, and then the gas limit, maximum amount of gas a transaction can consume. So gas prevents infinite loops and denial of service attacks, I see that earlier, and ensures miners are compensated for their computational resources. How that is clear. And here the smart contract lifecycle. The Solidity smart contract lifecycle, not the smart contract. First, you write the Solidity code, and then it's compiled to EVM bytecode, where the computer understands, and then it is deployed. You deploy the contract via transaction. Every smart contract you write is a transaction. Yeah, if you like, sorry, every smart contract you deploy a transaction. Like when you deploy a smart contract, you sign a transaction. Let me understand. Deploying a smart contract is a transaction, and then contract creation on the blockchain. The contract is created on the blockchain, and then contract stored with unique address. Every smart contract, right, has a unique address, just like the wallet address. Though yeah, it's a bit different. Yes, from it has some difference from your wallet address, right? And it interacts with the smart contract via transactions. You sign transactions interacting with the smart contract, and then you execute functions. Now, you pay for gas to execute functions. These functions that change the state. Functions that change the state of the smart contracts, you pay for those. If the functions are really like view, like data functions, there's no gas required. You don't pay for any gas. But if the function change the state of the smart contract, the transaction is required for that function to execute, and then gas is required, and then the state is updated. If there's no gas, the function, that execution cannot take place. So you have to have gas for that. This very changing function to execute. And for read-only functions, you don't need gas. So this is the life cycle of a Solidity smart contract. Let me zoom out so that you see it in full. Yeah, you guys can see it now. This is complete life cycle of an Ethereum smart contract. So let's share it with you guys. So some common security considerations in Solidity here. The entrance attack. When external contracts calls allow attackers to enter the calling contracts. And then you have the integer overflow in the flow. Like in other Solidity version 0. Like before this version we're currently using, arithmetic operations can overflow or underflow. Like using the units, you get unit from unit 8 to unit 256. So each have amount of MC number that can carry. So like if you use a bigger number on a smaller integer, it might overflow, or you probably use lower number on bigger integer, it will underflow. This is probably before this very version of Solidity you are using. So access control issues. Improperly secured functions can be called by unauthorized users. So you need to secure your functions properly to avoid being called by unauthorized users. And then you have gas limitation. Functions can fail if they exceed block gas limits. So you have to make sure you have enough gas for the function, for whatever functions you want to call. And so okay, and then we have front running transaction ordering manipulations by miners or other users. There are people whose job is just to manipulate contracts for their own gain. So you have to avoid your transaction or your smart contract being manipulated by these miners, these kind of people. And then let's talk about the development environment setup. Yeah, before we come to this, there's something that is quite expanded, deep explanation to all these things I want to show you guys. But okay, let's talk about this. To start developing Solidity, there are two things I'm going to tell you about. There's the normal, okay, like when using your VS Code editor to read the extension, there's the remix to write Solidity smart contract. That's online. It's an online IDE, which we are going to start with, and then you can use Solidity in VS Code with the Solidity extension. You have to download the extension. This one is web-based. This one is a local IDE. And then the development framework, there's hard hat, there's truffle, and there's foundry. I'm believe somebody going to take on this. And then there's local blockchain, there's Ganache, there's hard hat network, there's testing tools. We have Mocha, PHI, and Waffle. And then the wallet connection type integration, we have Web3.js, Ether.js, and other libraries. Yeah, these are the main integration libraries to use to integrate the smart contract with the front end to Solidity. Now here is a simple greeting smart contract for Solidity smart contract. I already explained what this is, and the version. This is the license identifier. So the contract keyword, name of the contract. And I showed you we declare the variable and we made it public. Here, this is private, meaning nobody outside this contract, nobody outside this contract can call this from any variable. It is private, can only be called by this contract. And then this constructor passing the greeting variable in, and then this a function greeting with no parameter. There's no call data here. It is public, the view. It only returns a string. This is a data function. It is not a state changing function. And then this is the state changing function with parameter inside the new greeting, depending on the time of the day. So let me show you. How do I open another file? Sorry, guys, because I'm trying to open my other file. Sorry, does anybody have any question? All right, thank you. I have another file I'm trying to open. Sorry, does anyone know how to open a second file on this? Okay. Okay. Here is I think this is supposed to be a detailed explanation of some of the things I mentioned and the other one. The EVM is fundamentally a stack-based decentralized virtual machine designed specifically for executing smart contracts and Ethereum virtual machine, Ethereum blockchain. Okay, yeah. The stack, like I said, the EVM uses a 1024 element stack with each element being 256 bits, 32 bytes, and operations pop arguments from the stack and push results back. I mentioned it earlier. And then the stack is the primary working memory for all computations. The stack depth is limited to prevent excessive resource consumption. Okay? And then memory, linear byte array that can be addressed at the byte level. And the volatile white claim between each transactions. for a new one to take place, and then expands as needed in 32 bits, 32 byte word. Sorry. Memory expansion cost gas with cost scaling quadratically to prevent abuse. Sorry, please get about me. A bit tense somehow. I'm like meeting most of you guys for the first time, though not physically. So I'm like that. In the next class, I'll be a bit better. So primarily used for temporary data storage during contracts and execution. That's for the memory, and then the storage. Persistent key value store where both keys and values are 256 bits. Persist between contracts, invocation, and transactions. Most expensive resource in the EVM, high gas cost. You see it earlier, as for the storage. And each contract has its own storage that cannot be directly accessed by other contracts. Sorry, excuse me, please. So each contract has its own storage that cannot be directly accessed by other contracts for security reasons. Storage is organized as macro, patricia, strive for efficient state verification. So execution context. When a contract is executed, it has access to core data. I explained this earlier. Input parameters to the function being called, return data, space to store data that will be returned to the caller. Yeah. Account information, address of the executing contract. I told you each contract has an address, balance of the contract account, and then the code of the contract itself, and the bytecode, and block information, the current block number, that contract, the block timestamp, the block difficulty, and gas limit. And your transaction information, you have the gas price, the origin address of the sender of the transaction, the sender address, original sender of the transaction, yeah, and then the sender address, immediate caller, and the value transferred in way at the lowest level of Ethereum. So you have the gas system. The gas system is a critical component of the EVM that ensures computational fairness. I said that earlier. The gas calculation, each gas has a fixed gas cost. Gas costs are proportional to computational complexity. The more complex the function, the more gas it consumes. And then memory expansion costs grow quadratically. See that earlier. Storage operations are the most expensive. And the gas limit transactions specify a maximum gas amount. Logs have a total gas limit adjustable by miners. And if execution exceeds gas limit, it reverts what keeps the gas. Okay, I did this very fire before doing the other one. So I totally forgot about it when I had to like do it down. This is basically the same with the other one, but with no good example. So I don't know if you guys understand. Maybe we just start. I'll just write a small smart contract for us to play around with. That's if you guys understand this theoretical part. Are you guys with me? Let me set up environments to play around with some smart contracts, explain more of the variables and functions to you guys.
Okay, Victor.
Yeah.
Tech Explorer has his hands raised.
Okay, please then. Okay, Explorer. Yeah,
Please,
please
I
go
want
ahead.
to ask, I want to ask,
Okay.
how does it relate to this Ethereum virtual machine computation? How does the gas usage relate to it? What is the relationship between this?
Sorry, I can't really hear you.
As I say, this gas usage, how does it relate to the Ethereum virtual machine computation? How does this gas usage relate to it?
Gas fee.
Gas usage. Can you hear me?
Yeah, gas what? Sorry.
I say, how does the gas usage relates to the Ethereum virtual machine? Like,
Okay,
Ethereum virtual machine,
gas usage.
how does it relate to it?
Okay, like I said, gas is used to like wait, talk about gas usage. Gas system is critical component of the EVM that ensures like this is the relationship. It ensures that every computational ensure computational fairness and prevent the denial of service attacks. Like how do I explain this? The gas here is not like the conventional gas, no. The pay gas in Ethereum. It's so in every transaction you perform in the Ethereum virtual machine, you have to pay some small amount of gas for that transaction to be carried out. And this here is the reason for each so that computational fairness and like to ensure computational fairness to make sure that this how do I put this? How do I get it? Can somebody like explain it to me to him with better it like whoever understands this should please help me explain to Explorer in a way that you can understand. Just like in the conventional world where okay, let's say for example you want to you have your cell phone and you want to make call. You have to pay for that call. If you don't in the conventional world, if you don't pay like if you don't pay for call you need, these privileges might be abused. The call privilege might be abused. People will abuse that privilege if you have free calls. Okay, like for example, when you do some cheat code, you have cheat code where you have free data to browse the internet. Like somebody hacked into the MTN server or to get cheat code for people to use. You see people abusing that privilege, using it to download more stuff they don't even need, heavy stuff on the internet, stuff they don't even like need in their phones. So in the Ethereum, you have to pay some amount of gas to carry out the transaction, so that there'll be I don't know. Should I say there'll be regulations or yeah in the competitional in the competition
Okay,
stuff
I
like that.
understand.
Yeah I'll look for a better way to explain it for you before the end of this class. Sure. But let me set up a mix ID so we can play around with some codes.
Yeah, Obed has raised his hands. Obed.
Okay. Okay, sorry. You can speak, please. I think somebody has a question.
So, I wanted to contribute on the issue of the gas cost. I don't know if
Okay.
you feel like you really understand. Okay, I think we have understood what you said.
Sorry?
I said I want to contribute. Like you asked if there is anyone that contributes on this topic.
Okay, yeah, please go ahead. Go
We
ahead.
have understood what you explained.
Okay, Explorer, I think somebody wants to explain better to you, or you already
Okay.
understand. Robert, please go ahead. Hello, I am sharing another screen. I don't know if you can see it. The Remix IDE. Can you guys see the screen? I think I have to stop sharing and okay, you can see the IDE. Right.
Yes, sir, we can see.
Okay. So let me explain what this is the Remix IDE. Just go to your Google, your browser, and type Remix IDE, and then so we can work together. Let me give you 2 minutes to do that. Go to your Remix IDE. Sorry, go to your browser or open a different tab and then type Remix IDE, and then open it. Let's create a smart contract. Let me know when you're done. Can we proceed? Thank you, Richard, for sharing that. For those of you who don't, you can check the.
Yes, sir. Someone has his hands raised.
Okay, 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 Dani, what's up? Dani, please go ahead.
Um, Sir Victor, I don't know. I want to elaborate more on what the question Tech Explorer asked. So I
Okay.
don't know if my explanation is going to do justification. Anyways, I'll just try. By what you're trying, but based on what you're trying to explain and how I understood, let me just give an example. For instance, let's say a telecommunication company. Let me just use country for instance. Let's say we in Nigeria here versus people in Ghana. If for instance now like this, we in Nigeria we need to buy we need to buy data for us to be able to surf the internet and maybe surf the internet and do other stuff. Meanwhile, people in Ghana don't need to buy data. Internet is free for them. You find out that to the computational fairness will not be there because people in Ghana are going to make use of the internet more than us in Nigeria. Maybe like get more access to other things. They might even develop faster than us because we need to pay, and maybe data is very very expensive. We need to pay. So the computational fairness I understood there is okay. We all have to pay to let me say for instance, we all have to pay to get access to it. So there shouldn't be partiality or biasness there. I don't know if you understand or if this actually answers the question.
Yeah,
So
yeah,
this is for instance.
yeah, that's cool. That's cool. Yeah,
Okay.
great.
Thank you.
Thank you very much, Moses. And Chupu, Obed, you have your hand raised. Please go ahead.
Okay, I think I also want to contribute
Okay.
the gas stuff. Okay, and you know that in blockchain, especially in Ethereum, but we are talking about Ethereum to prevent. I'm talking about how gas prevents spamming. So you know that when somebody comes to write malicious code that might be running, might be crawling around the blockchain and doing some certain things, maybe stealing some people's fund and all those stuff. Um, the guards will prevent the person because um, every action or every state change in a blockchain, the Ethereum blockchain, you have to pay for it. And the more difficult or the more complex your malicious code gets, the more gas fee you pay. So the implementation of that helps prevent spamming and from people that might be kind of pushing some fake transactions, which is malicious code or running from or from running from malicious code that might be stealing people's money or something that might be causing them danger in the blockchain. So these guards help in preventing them because it's something like once you are doing something, if you like do it 100 times, it will be costing you, like you'll be paying money. So if you kind of limit the amount of spamming that people might be doing in the blockchain. So that's how I
Okay, thank you very much. Chukwu. That's great. So I have even like learned more from from a good explanation from Tali and Chukwu. Thank you very much, guys. Thank you. That's very helpful. Explorer, I don't know if you understand now. Yeah, thank you. Okay. So, do you have your ID ready? The remote ID. All right. Just a minute, please. Okay. So now let's go to our IDE. Next thing to users. Okay, this is the remix IDE for writing Ethereum smart contract. So we're writing small smart contract here. You can create a folder, you can create a file in the workspace. And there's an angel terminal where you can see all the actions. Let's create a new file. So let's create a workspace. We need to create a workspace. Yes, this is the default workspace. You can create a new one. You can even sign in. You can create account and create new workspace. This is the default workspace. You can have to. I need to have some. This is my work. Well, okay. Let's create our own workspace. So let's call it FiTech. So here we create I think I'll delete all this. And we'll create our own file. Create a folder. So, sorry, to create a smart, Ethereum smart contract, Solidity smart contract, you name it and then you use the file extension .so feo. This shows that it is a Solidity smart contract. You know, every programming language have their file extension name. JavaScript is JS and Python is PY, or smart or Solidity is FOL, short form of so, show that it is a Solidity smart contract. When I started learning, I learned Solidity before learning Cairo. So when I started learning Cairo, I couldn't wait for us to start writing code. So I wanted to see what the file extension name would look like. I was hoping it would be like CR, since every other programming language has at least two or three letters as their file extension name. So I was hoping to see that CR or CR. But then I was surprised to see the full name, right? For example, you say my first contract.cairo. It was very funny. It seems very weird to me that you have to use the full name. Like Rust, you have RS for Rust. So you can go back to our work and then I want to show you. Let's play around with the smart contract. I'll show you guys here.
Victor,
Yeah.
please can you share the link to the source code?
Sorry.
Can you share the link to the source code with us?
Oh, okay. Yeah. Let me do that. Somebody have it ready. Okay, I just shared the link.
All right, thank you.
Sorry, Richard, is it the guy from Ghana?
Yes, sir.
Oh, okay. Welcome.
Thank you.
So here is a simple smart contract. Like I said before you write a Solidity smart contract, you have to specify the license. If I remove this now,
Peter.
Yeah.
I think it requires permission. You need to give us access.
No access to it.
Okay, I just changed the I just changed permission now. I don't know. Can you access it now? Can you access it now?
No, it's like you continue after we watch the video. Honestly.
Okay. 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 Yeah. That's I've seen it. Permission. I think I've changed the permission again. It's just to be clear. Should I share the link again? I think it's the same link. Let me just share it. Try it again, guys. Working. Okay, thank you. Yeah. So I just removed the license. You see, it is flagging an error. What's the error? Asking for. Okay, sorry, it's flagging a warning. It's asking for the license. It might look commented out, but it is working. So you have to have that there for it to work. So if I undo, bring the listing back, you see the warning goes away. And then you have to specify the version, compiler version you want to use. Okay, here we are saying you should use version 0.8.17. From this version upward, you should not use anything below this version. So from this version up to the latest version, you can use. So this is where you come and like check different version. This is the latest version so far. I think we are in version 8. These are all the version. This is the one we're currently using. This you can use from this version up to this very version. So the latest version, which is 0.8.26, I think. So here we are declaring the contracts. Like I said, you declare the key, use the keyword contracts, and then the name of the contract. The name of the contract must start with capital letter. You must start the name with capital letter. In this case, we're saying my first contract. This name is not the same with this. They are different. They are different. So let me walk you around the looks like the IDE. Here, this is where you come and choose the version you want to use, the version of compiler you want to use. So if you want to compile your, like, let's say you want to compile this now, this you click here, it compiles this. To compile this contract for you. So here we have different virtual machines here. Like these are just virtual machines for the EVM. These are not minutes. You can just use this to play around, like to learn your Solidity. There are different virtual machines. One of the popular ones we used to use back then is in London. It's quite noisy. This one is for mainnet. How is it? Main network. Okay. There used to be one London thing like that. I don't know why it's long I remixed to write this thing. And then here there are different addresses here. You can choose to either or deploy a contract or play around with the contracts. You can use any of these. Each of them have 100 fake ethers. These ethers are not real. They are fake. So just use them to play around, to deploy contracts and execute different transactions. And here you have the gas, the estimated gas in each the estimated gas limit is this amount here. This is about $300. Which $300 it should be getting there, right? 1, 7, 3, 9, 5, 6, 3 million. So we have the value here in way. Okay, like I said, there are 4 different should I have the denomination? This is the highest ether, the fillet, is gray, and the smallest is the way, which pay transaction fee. And then this is the name of these are smart contracts. You can deploy multiple smart contracts and like pick them in. So this is where you deploy the contracts. You want to deploy this contract. Once you click here, the contract is deployed and the transaction takes place. Here you can see here that our smart contract has been deployed. Here you get details about the smart contract that was deployed. I don't know if you guys can hear me clearly. We're a bit far from the mic. Nice one. So here you get the status transaction mine, and it is a success. We deployed it successfully, and transaction hash, the block number, one, and the contract address. Like I said, each smart contract to deploy to the blockchain has contract address, a unique contract address. So now let's explain this smart contract. Okay, this smart contract is a simple smart contract that just simply change the number. Okay, now each function is showing you the amount of gas you are going to take when you execute them. The constructor, when you see the constructor, this is the gas amount you pay when you call this. Okay, I believe you guys can see this. Let me just read this. I don't know if you can read this. Estimated creation cost is the amount of gas. Estimated full deposit cost. Like this is the first one here is the creation cost, the gas cost for the creation, the function creation, and then this is the deposit cost for this constructor. And then there's this one. Something like the amount of gas you use, infinite gas. I don't know what this means, but we'll get to understand that in the future. So here we are declaring the contract, my first contract, and then we are declaring a variable, a uint, or explain the data type. Tomorrow we'll start explaining like we discuss the data type for Solidity. So today I'm walking you through this smart contract and like we play around and see what it does. So here we are passing in 256, making public for every contract. Any contract outside this contract can see and call this function because it is public. And then the name is my number. We are not passing any value into it. So by default, it is 0. If I remove this 256 from this, you can still use it like this. By default, it will be 256. You can use 8, which is the lowest. It is shouting because this is probably due to should I say it might underfill because here we are using the smallest if I leave it like it will not shout because by default it is 256, but when I add that with 8, it will shout because probably due to underflow. I believe we are taking higher number here, then we are like using a smaller int to take that number. So by default it is 256. Let's do it first, and then we are passing an address with owner as a name. And here we are declaring events, like I explained earlier, we are declaring events. Whenever this number changes, whenever the value of my number changes, it will emit it. So the passing a constructor with the message of sender and the number. And here we are giving my number a value of 0, which is still the same thing here as if I think I already deployed this contract, right? Okay. Okay, I'll come back in. So and now here we are declaring a modifier with the name of only owner. This is this means that only the owner can call a particular function. Whichever function we pass this identifier to can only be called by the owner, as the owner of the contract or yeah. So and here we are declaring a function with set number, which is a state setter, and it's a setter function, a state changing function. And then we are taking an input here, call data, taking the call data here, and then we are making it public, and then we are saying that only the owner can call this very function. If you are not, if anybody outside the owner calls this function, he or she will get this error message. Only the owner can call this function. So, and then we are setting the call data here to be whatever the value of this. So we are changing this. We're changing the value of this variable here. This is my number to be whatever you input here. Because this is like an input. It's call data. It's like an input. Whatever you add here will become the value of this. I hope you guys understand. So, and then we are emitting the changed number. So whenever you change, whenever this variable changes, like if it changes to 1, it will emit to tell you, okay, it's you, to give you the value of the new number, and then the address of whoever called the function. And then here we are getting the value, the new value. That's what we're getting here. To do that, you just function, if you get a function, it doesn't change the state, it only views the value of this number here, my number. So we make it public, make it view, and returns the 256, which is the value of this. So now let's play around with this the contract. So we deploy the contract. Initially it has 0, the balance here is 0. We don't like send any hits to it. So initially, this right here is this intake here, this call data. Whatever you put here becomes the value of my number. If I call my number now, it shows you 0. The value of my number now is 0. There's nothing inside. Then check the owner. Who is the owner? The owner is the address. This address of the contract, all right? I'm not wrong. The address of the contract is the same address as the address of the Spanish. That's the address, the contract address. Okay. I believe this and these are the same, right? Yeah. No, they are not. This is the address of the, here is the address of the owner of this contract. Whoever will call the function, this is the address. So if I come here now and let's say I add 1. So, okay. I clicked on the wrong button. So you see, I added one and the transaction was successful. So if I come back here now and try to get number, the value of my number has changed. Initially, the value of my number was 0. Then I added 1 and I transact, and I come back to get the value by calling this function. Initially, the value of my number was 0 when I called this very function, function, and then I added 1. I added 1. Using this call it, I added 1, and then transact by calling this function. This is the setup function. This is the function new number. Then I added 1. Sorry, set number, not new number. Set number. This is the function I called set number. Added 1 line. I called function, and then I come back to this function to call the function get number, and then the value changed. If I come back here now, and then let's say I add 5, the value will change. Once I come here, sorry, get number. If the value have changed, the new value is 5. If I click here now, you get 5. My number. I don't know. You guys are getting this right? You guys getting this?
Sorry, sir. Please, me, I will not lie you. Although I'll go back and try to reread and watch the videos, but please, just in order for us to follow, because all those data types we did not understand, but we understand what is going on when you are compiling it. Yeah.
Okay. Yeah, we have not really talked about the data type yet. I'll talk more on the data type. Today's lecture is supposed to be about Solidity and Ethereum, which I just explained to you guys. So right now, I'm just like trying to play around with Solidity smart contracts to show you how they behave, their life cycle, and the rest. But tomorrow we would like talk more on each data type, their behavior, what they do, and all that. Thank you. So, besides Tech Explorer, who else doesn't understand, and what do you not understand? I should probably explain this like for this very one, this data type for you guys today. Let me play around with this. This my number. We can hide my number. Since we already have a getter function to get my number, we can change this from public to private. So when I delete this contract, you can delete contract, you can delete and deploy contract, and then you deploy. Like first, let me compile. It's compiled. If there's any error, this will not compile. If you see, like if you show some error, since it's showing green, that means there's no error and it's compiled. So we come here to deploy. Now when we open this, you will not see my number because it is set to private. Private means no contract or somebody outside this contract and call this function. They cannot even see the function. Public is showing the variable for other contracts to see the call. But private hides it. There's external, there's private, there's public. I think there are about 3 or so. Private, external, and public. Then if you put it in private, every contract outside this can see and call. You put it in public. If you put it in private, only this contract can see and call this function. So here we are saying this variable should be private, but then we can still get the value of this by calling this function get number. Now if you click on get number, you get 0 because initially we defined it to be 0. Let's say I remove this from here and I give it a value of 2. Then I come here, I delete. Let's compile. And let's deploy. Deploy. Did you guys notice anytime I deploy, or whenever I deploy or call a function, this the amount of ethers there reduces because we are paying gas fee with this ethers here. Anytime you call any state changing function, or anytime you deploy a contract, which is also state changing, it will reduce the amount of ethers here will reduce. We're using this very account. If you check now, every other account here has complete 100 ethers, but this one has reduced to 99.9999 something. So let's continue. So I've deployed the contract. If I come here now and click on get number, what do you think I'll have? Somebody should like unmute their mic and tell me what I'll get if I click. I know you guys have probably tried it. I want somebody to tell me what I'll get when I click on that. Anybody? I should have 5, right? Sorry, okay, 2, not 5. Sorry, I added 2. But if I don't specify anything here, and this one is commented out, here using the 256, checking it private, and there's no value to it. When I delete, anytime you like change anything on this contract, you have to redeploy. You have to deploy again. You have to delete the old one and deploy again. So let's compile, and always compile this to see if there's error. There's no error, so you deploy. So please, this time around, I want you guys to answer. If I click on this get number function, if I call this function, what will be the value of my number? Please, I want somebody to tell me. But I said it earlier. By default, if you don't add any value to it, it will give you a default value. So you can tell me what I will get by calling that function if I call that function. Nobody? Are you guys with me? Or am I talking to myself?
So I think it's a null value.
No. Not no. I should have 0. If you don't specify any value, if you don't give it any value, you have a default of 0. You see, 0. It's not none. You get it. And also the int, if you don't specify the type of int you want, 5, you have a default of 256. Let's say I change it to 8, then I need to change it here also. Just yeah, here also. If you don't specify any size, the size of the integer I want to use, the unsigned integer I want to use, it will give you a default of 256. That is why when I did not, for example, you notice that if I remove this 256 from here and I don't remove this ones, there's no error. There's no error because it is still seeing this as the same as this. It is still the same 256. You see, it's showing 256. Once I change it to 8, I get an error because then I have to change this one to match this one. But if I don't specify it to be a size of 8, I will not have an error. I don't know if you guys understand that. By default, any variable you don't assign any value to, like for integers, to give you 0. If it's for bool, Next they do. Oh, we give you this image is changed. By default, this is false. If I over here, you see, this is good by default. This is false. I don't know if you guys understand. By default, this unit is 256. The value of this by default is 0 since we are not specifying it in here. Unless you come here, you can either give it a value here or you come to the constructor and then you comment this out to give it a value here, which is this value and this, they are still the same thing. Even if you don't do this, there will not be any error. So you still have the same value of 0, default value of 0. I don't know if you guys understand.
Please, I want to ask him if you put the value that place you put 0. If you put the value, maybe if you put another value in the is it contract? Then let me say I put 10, then put in the constructor I put 11. Like when I put 11 in the constructor, will it automatically change in the first one? That unit private.
Let me understand what you're saying. Let me do this. You mean if I put 10 here?
Yeah, 10 is the constructor.
Then
I'm not saying if you change the constructor value, will it automatically change in the first one? The first my first contract.
the first contract. Yeah, they are like in the state variable here. You're talking about this one. Like if I
Yeah, will it change?
here,
Yes. If you change the number in the constructor, will it automatically change that value to be the same with the contract that state variable?
I believe this one will take preference. The constructor will take preference. Yeah, it's compiling. So let's deploy and see. First, I need to delete this one. So deploy successfully. So if I click get my number now, I should get 11. So the constructor will take preference. The constructor is I don't know how to put it. The value of the constructor that is more preferable or more powerful than the state variable here.
Okay, that is you take control over the above state variable.
Yeah, take control over this one. Over the I believe this has nothing to do with scooping. So even if I bring this this one down below the constructor, it should still do the same. When you delete this, goodbye. Yeah, it's still the same thing. So the constructor should take preference and then the value, whatever value the constructor has will be the one that the contract will adopt. You understand?
I understand.
Okay. So any other question from anybody? So who doesn't understand anything? Let me explain. Should I ask my own questions? Maybe I should ask my own question. Who understands what modifier is? What does modifier do? What does it do? What do we use modifiers for in Solidity smart contract? Should I call names? Why are people leaving? I've less than 20 people here now. Should I call him?
Probably we don't. Sorry, good morning. Probably we don't understand, but we don't want to indicate that we don't understand. But for me, Sha, I'm just joining in. So I was thinking maybe later I'll watch the video so that I can understand what you taught already.
No, please. If anybody doesn't understand,
I
please
think
don't.
I think let me see. I think it changed the behavior of other functions.
No, it doesn't change the behavior of the function. Like you need like modifier. They modify. Okay, yeah, it did changes the behavior. You use modifiers to customize should I say actions. You can say use modifier to customize actions for a functions to adopt. Like for example, in this contract now we are saying we are creating a customized message, customized action. Here we're saying only owner can call this function. Right? Only the owner can call this function. If any other contract, like any other person, any other address that does not belong to the owner of this contract calls this function, they should get this message. Only the owner can call this function. So yeah, modifier can change the behavior of the function. Actually, yeah, modify the behavior of the function. You can use them to customize, to create customizable actions for messages to adopt. You do more of this when you start writing deeper code. Tomorrow, probably, like when I go to teach you data type, all the data types and their functions, their behavior, how to integrate them into Solidity smart contract. So, okay, now let me ask another question. What is a data function? Please, Tech Junkie, please, if anybody doesn't understand, it is good to have not leave the call. Leaving the call discourages the. Now I'm feeling like maybe I'm a bit boring. Do I know? Yeah, it's a bit boring. Even me personally, I don't like theory that much. I prefer theory. I prefer practicals. That's the reason I even switch to like showing a short code of how this thing works. Anybody doesn't understand anything, ask. Not leave the call, please. Okay.
Thank you, sir.
You're welcome.
Can you hear me?
Yeah, sorry.
I think data functions are the function that enables Ethereum Earth transfer in the system.
Yeah, thank you. But that is what data functions. Data functions are functions that these functions don't change state of don't change the contract state. They are just there to show you their view, like view only. They only return the value of a particular function or data. You don't use them to get values of other functions or variables. For instance, we're using this get number to get the value of number. We use it to get the value of number at the initial stage and after number changes. So data functions are functions that don't change the state of the smart contracts. They're only there to return the value of, like, we don't use them to send Ethereum. We use them to get the value. Like for example, if I call this function, like I did earlier, okay, I changed something. I need to get this and then redeploy. So when I call this function, at first it should give me 0. When I call, this is the function, this is the data function. It won't change anything. You see, there will be no transaction. There will be no transaction when I call this data function. This is the function I'm calling. This is the data function I'm calling. It will get. There's no input data. It is public. It is view. Just to view the number, the value of the variable, by number variable, and then it will return the unit 256, which is what we declared here to be the data type for my number. So when I call this get function, there's no transaction, there's no gas fee, there's nothing. This is all you get.
Okay.
So there's no gas. You see, you not see any gas or anything. But once I call this one requires transaction, requires an input, which is this call it right here. This is the function I'm trying to call now. The set number function. This is the setter function. It changes the state of the contract. This entails gas fees. We call this function you pay gas fee because you are signing the contract. You are changing the state of the smart contract. You are adding to the blockchain. So initially, this is why am I getting 11? Here, I think this is the code. You need to compile. Sorry, you're not compiling. Always compile. Anytime you make any changes, make sure you compile before you deploy. See the mistake I just made now. So once you compile, you deploy. So let's call that getter function again. See this thing I just deploy the variable I just this boolean variable I declared here because I set it to public, so you can see it in. So if I call this get function, the getter function, you see the value is 0, there's no transaction, there's no gas fee paid, and all that. Execution cost, sorry. Cost only applies when called by the contract. Probably this is being called outside the contract based on what I'm seeing here. So when I call this function, here you pay gas fee. Let's say I add 5 and then okay, here there's a transaction here. Get number. Transact to okay. You see the difference. This one is called to my first contract. Get number. This one is transact to my first contract. This is the transaction. So it is and this is the transaction. This is just calling it. There's no state changing. This is not a state changing function. It doesn't change anything. But this one changes the state. It adds to the blockchain. So here, success and this transaction hash. In this one, there was no transaction hash because there was no transaction. From the caller, this is the caller's address. Hope you guys can see the difference. So this any function you can call to send Ethereum is a state changing function. Getter function cannot send Ethereum. You can only get the value of some other variables in the contract. So when I call this now, I think that this value should change. Should have another. Yeah, it's 5 now. So you can see here again. There was no transaction. It's just a call. Just call the function. So I hope you guys understand the difference between setter and getter functions in Solidity.
Yes, sir.
Okay. If somebody's reading, take Explorer. You have your hands up. Hello, Explorer. You're raising your hands. Do you have any question or contribution?
What I want to ask, can this sorry for drawing you back. Can this modifier be used across multiple chains, like multiple chains?
Multiple chains or multiple functions?
Multiple functions. I made a mistake.
Yes. You can say you only want the owner. Since here we are saying only the owner should call this function. That's why you're passing it here. Only owner. If you want only the owner to get the value, you can also pass it here. It should be behind the return. So you can say only owner. So you can pass it across multiple functions. You see that? Blocks. If you have 10 functions, 20 functions, and you want only the owner, you want only a a particular person to call this function, you can pass it across multiple functions. Did I answer your question? Okay.
Yeah.
What else have their hands? Johnson. Okay.
Okay,
Johnson.
sir. Sorry, my question is on this modifier. So that modifier works like an error message if a statement is not true, like a conditional statement in JavaScript.
Yeah, you can use it. That's why I say you can use it to create customizable messages, including error messages. Yeah, you can use modifier to create error messages. You get? All right. Any other question from anybody at all? Any question? Even not from here, you can ask questions from here. What we explained here. Another is another. You can ask questions from here. You have the life cycle of Solidity smart contract. Another. Yeah, there's another smart contract here. Okay, I think we have done this. Who didn't open this? Like, who did not open Remix on their machine? Everybody opened Remix, right? Everybody's following along. So if I give you assignments to write this, you already have it with you. So any other question, please? Or do we all understand them? Should I ask my own question again? Okay, I said something about the constructor earlier, right? I said something about the constructor earlier. I said the constructor can only do something. I don't know. I forgot what I said. Can remind me of what I said about the constructor. And the reason why we are passing the message of sender inside there is for us to be able to define this. Yeah, somebody's saying something. Go ahead.
Constructor, as I was trying to understand, like it automatically executes once when a contract is being deployed.
Thank you.
Okay.
Constructor can only be called once when the contract is deployed to the blockchain. Thank you very much, Techie. You understand it. So please, anybody that doesn't understand anything should please ask me. Somebody else to me. Okay, yeah. Bella.
Okay, good morning. Please, can you share that screen? There is one thing I wanted to ask. In that code.
Yeah, this is the code.
So, when you are calling this the set number, you added this only owner. Is it the modifier? Like, what is he exactly doing in that set number code?
Sorry, come again, please.
Like the only owner modifier that you are calling beside that set number function. What does it do? Like, what is it doing there? Like,
this is very well, right?
Yes.
Okay, this is when we declare only owner modifier.
Yes.
We are saying for you to declare, for you to use the modifier, you have to require this modifier. This only owner requires that. Sorry, can you turn off the mic?
Okay.
This modifier requires that only the owner can carry out a particular action, can take a particular action. Here we are not stating the particular action you want to take. Where you state the action is where you want the action taken is where you render, like when you call this function. Here we are declaring the function, the modifier function. and you're giving it name only owner, and it requires that only the owner message your sender. That's the owner. You're declaring like
Okay.
only the owner. Now, wherever you pass this function, whenever you pass this modifier function, only the owner can can call that function. Like for example, you are passing this in this set number function. Anybody outside, anybody outside this country, like how do I put it? Any address that is not the address of the owner of this contract cannot call this function, this very function. That's why you're passing it here. Only owner. This only owner here is this function here. We are saying that only the owner of this contract can call this very function. And we're also passing it here to show example that we can pass it across multiple functions, different functions. Normally it shouldn't.
I understand. Okay. So it's just like it's doing a check to be sure that the
Yes,
owner
exactly.
is the owner
Yes,
before,
the contract, the address
just
of the
like a
owner of that function.
okay.
Yeah, yeah, I'm listening.
Just like a middleware, maybe in middleware in API, something like that. Something like that.
Yeah, you know.
Okay, so it's
But
just acting as a check before the person will be able to run the.
yeah,
So if it's not the owner, then it will return
no, it
this
will get yeah,
message.
to get this you get this message.
Okay.
You can
Okay.
also use it to check that, and you can also declare um another message to check that an address, like example where is an input for address, to make sure that the address is not zero address or address zero, or there's at least an input. I don't need to understand where you're supposed to input an address. Make sure there's an address in it. There's an actual address, and that address is not address zero. I don't know, you guys. Like in the future, you get to know what address zero is. Address zero is something like this, I think. Sorry. I think something like this. This should be address zero. It's zero address. So you can also use it to check that an input of address is, and it's not address zero, and there's an actual address in that input, or call it a. Okay, any other question, please? Is there anything you guys don't understand here?
I want to ask, can
Okay.
a constructor have like in a contract? Can they have multiple constructors in a
No,
contract?
no, you can only have one constructor. Any value you want to pass into any constructor, you pass it inside there. You can only
Okay.
have one constructor. You can't have multiple constructors. As soon as I create another constructor here, you it might not compare. You see there's an error here. There's an error. It's shouting, right? Let me put something inside there and see if you cannot have multiple constructors. You can only have one constructor. Creation error, more than one constructor is fine. Can you see that? So you can only
Yeah, I
have
can
one.
see.
You can only have one constructor. Why would you even want to have multiple constructors? You can have multiple modifiers. You can have multiple functions, data functions, data functions. You can have 20 variables. You can define another unit here. Let's say you want another unit, 2 5. You can define a different units, make it public. And then let's say Here's private number. Always close, always terminate it with semicolon. So you can have multiple links, you can have different types of, you can have different sizes, you can have, at least you can have multiple addresses. Yep.
Okay.
Multiple addresses. Have a question?
No.
You can set this to external. Like you can actually set address to external, right? You can set to external. Let's say public. You can have multiple, like, but you can only have one constructor. So you guys don't have any question here, right? I explained this earlier.
I have a question.
Okay, what's the question, please?
Okay, so in a Solidity contract, is it possible to write a contract without adding constructor, or
Yes.
is it necessary you must put it?
You can write contract without adding constructor, depending on what you want. You can write contract without constructor. Like I said earlier, we have this constructor here because we needed to define, right? We needed to define this modifier. If I take out this constructor now, I compile, it's compiled. Then we delete the old one and then we deploy. We deploy it. There's no error. We still have all our variables. Let's get the number of 0 because there's nothing inside there. See, it's set to default. The default is 0 since we didn't add any value. I see that earlier. So you see there's no constructor, and then our contract is working fine. There's no value there. Give you, this is 0 address. Yeah, this is what I was trying to show you guys earlier. If you don't give any value, here we defined an address, made it public, my address. We didn't give it any value, and it defaults to 0 address. You can see here, defaults to 0 address. But if I try to get owner address, it will still default to 0 address because here we already taken out the constructor. In this constructor now, we're specifying that the owner of this contract is the sender. Do you understand? Here in this constructor, we specify that the owner of this contract is the sender. If I like compile, if I uncomment this now, like bring back the constructor and then compile and send again and call the function, you see it will have an address, the address of this smart contract. Now with this, now anybody can call this function because there's no address set to the owner. There's no address set to this. Since we are commenting this out, this thing is useless. Anybody can call this function because this is here we are having 0 address. That's why we need a constructor. For you to define, to use the modifier, you need the constructor. So you can pass in the owner of the owner of the contract as the sender, and then we use that to create the modifier. Do you guys understand why we need constructor?
Yes. Thank you.
So the owner now is giving 0 address, and this one is also giving 0 address. This one will be false. By default, it is false. Any Boolean variable by default, in fact, by default, all variables are, I think, let's say negative or false, 0. So if I come here now and I change the state of this contract by adding transact, an error. The contract has been reverted to the initial state. Where was the error? Okay, sorry. Yeah, I made a mistake. I can no longer call this contract this function because here it's showing that I am not the owner. Understand? It's showing that I am not the owner. I'm trying to see if I can see that, if I'll see that error message. Yeah. Can you guys see this? Showing that I'm not the owner.
Yes, you can.
Because I'm actually the owner of this. I deployed this contract, but the the address of this contract is not set as the owner of the message sender anymore. Since I removed the contract, that's why I cannot call this function. You see here, reason provided by the contract, only the owner can call this function. Because I commented this out. Now I'm not being viewed as the owner of the contract anymore. It's more like an outsider calling the contract. So I'm getting that error. If I go back and uncomment this, and then I delete, compile, when I deploy, if you call the owner address this time around, the owner, which is this one right here, you see the address of the contract. Now it is no more zero address. Now I can call this function, this set number function, because the constructor is back and it is set, the contract address is set as the message sender, as the sender of this, from the, like, whoever deployed this contract now is the sender. The address is set as the sender's address. So I can call this function to see to successful. And if I come back here and get number, number has changed. So we need constructors to set some particular messages, error messages. Oh, we need constructors to be able to set some should I say commands. For example, we set the owner of the contract to be the sender. Now this gives the sender power over every other person outside this contract. He alone can do some particular things, like for example, he alone can call this very function. Also, you can pass this modifier across different functions. And stuff like that. Any other questions, please? Please ask me questions. Let me explain. Sorry.
Listen. Okay, so instead of declaring initializing the variable inside the constructor, is there a way someone can, that place you declare the variable, is it possible to initialize it straight, like the way you have in the variable where you declare the variable?
Yeah.
Like where you have address, public, owner.
Yeah.
Can we say equals to msg.sender, or must it be inside the constructor? Or is there a reason why it should be inside the constructor?
Yeah, sorry. There's someone on my door. You cannot. That's why we have the constructor. That's the specific reason why we have this constructor. You cannot, for example, I think that's a very nice question. Let's try it and see. let's say I come down here and say owner equals to message the sender. As you can see, it cannot work like that. Hello, Abiola, right? You have to
Okay, I'm waiting.
you have to use the constructor to like declare this. You can't just
Okay, to initialize. Okay.
you cannot do it outside the constructor.
Okay.
Tech Explorer, you have your hands up, right? You have a question.
No, my hand is not raised though.
Okay, I think he's referring to me. Sorry, I have I think 1,000,001 questions, but the problem is that I joined late, and just to be frankly speaking, this is the first time I'm seeing a smart contract being coded. Yeah, but the thing is, for me to start asking questions now is like I'm taking everybody back to the beginning, because honestly, to be frankly speaking, I don't really understand most of the things here. Like seeing this constructor having a faded gas 266,402, gas 236,800, and all those things. I have questions about those things, but I just don't want to take everybody back. So I don't know if it's fair for me to still ask the questions, because honestly, for me to ask now, that means we have to start from beginning and start bringing everything down, because I won't. There are things I won't understand except you explain from the beginning. You understand?
Yeah,
So I don't know. I just don't want to be biased, and I don't want to be
I
self-centered.
understand. Wait, besides Tech Junkie, how many other people joined late? Let me see if I can like use the remaining. I think we have to take this left to brush through what we went through. We did not start from here, Tech Junkie. We did not start from here. We actually started from the theoretical part of it, where I explained um, everything about Solidity. I know you missed all this place, right? You're not here.
Honestly.
But I shared the link to this Hack MD workspace to group the call, so you can go through. But here I can just, like I said earlier, I made this thing self-explanatory. Like I broke it down to like first explanation, so I don't have to explain much. Just by reading, I believe you can understand. Whenever you don't understand, you can maybe ask questions in this class or read more. But I can still like brush through this thing. And as for the gas, this thing you're seeing here. Sorry, let me take this out. But the gas is still you're seeing here. I did not really go into the explanation for this, but here is what I just explained. The estimated cost. This thing you're seeing, the first set of shaded gas, is the amount of gas needed to create this constructor in the blockchain, right? And then the other one, I think I need more. I need to like more. But if personally, I've not seen this like double this thing before. This is what I used to see: infinite gas, like the amount of gas you need to call a particular function. This is my first time seeing. But to my understanding, here is the amount of gas you need to create this on the blockchain, I believe. And then here is another amount of gas you need to deposit cost. Probably to call this particular function, this construct on the blockchain. I need to like read more on this gas thing to explain to you in the next class. But here I can like brush through, go back and brush through. So this is the original topic for today. So it was like very short introduction to Solidity and EVM, Ethereum virtual machine. You already know what Solidity is. I believe somebody treated Solidity for now. Solidity is statically typed object-oriented programming language. Statically typed in the sense that whenever you're declaring a variable, you have to specify which type of variable you're declaring, not like JavaScript. In JavaScript, you just let John equals to whatever, or let number equals to let num equals to 0. In JavaScript, you can use equals to 0. Now we don't know which variable. We don't know what type of variable this is. We are not, in fact, in JavaScript, you cannot do that in Solidity. That's why it is called statically typed language. You need to specify exactly which type of variable you are using. Here we're using the integer, unsigned integer, the uint. There's also int. It's how to declare an int.
Sorry.
Hello?
Sorry, sir. I have a question. Does it mean that I need to understand JavaScript before going into Solidity? Because honestly, I have no idea about JavaScript. The only thing I know is Python.
No. The only thing you need to have basic knowledge of front end for you to like go into blockchain Web3. But you already have that knowledge since you know Python. You must not understand JavaScript, but at least you must have knowledge of front end, like the basic knowledge. You know, the basic knowledge in tech, I think it's front end. You have to understand HTML, CSS, and since you already know Python is enough. You mustn't understand JavaScript. I'm just making reference to JavaScript. Like in JavaScript, you can just declare a variable without tying it to a particular type of data. It's a data type. But here you cannot do that. You must declare, you must state what type of data type you are using. That's what you're doing here. In the first line here, you're using unsigned integer. In the second, we are using an integer. This integer, and in the third one, we are using another unsigned integer. So that's how you do. You must tell us the type of, you must tell the compiler a type of data you are declaring. Unlike JavaScript or probably Python. I believe Python is not a statically typed language. You can do this in Python, right? Tech junkie.
Yeah.
Okay, you cannot do this here. It won't work. So that's what they mean by statically typed language, programming language. So here the key characteristics of Solidity is it is contact oriented. Solidity can only be used to write smart contracts. You cannot use it to do something back end. Though most times we refer to, me personally, I refer to smart contract as back end. I don't know why. So whenever somebody asks me what do you do, sometimes I tell them I'm full stack, back end, front end, meaning I write smart contract and I do something, but it is not actually back end. It's blockchain. Different from back end where you use Node.js, Nest.js, all those to write. So it is contract oriented language. It is used primarily for Ethereum smart contracts. Yeah. But now other chains are adopting Solidity to write their smart contract, not only Ethereum. So it's compiled to bytecode that runs on the EVM. Normally, the computer doesn't understand all this thing you wrote here. All this system. Okay, I think I can show you the bytecode, right? What's this place? The place where it's okay. This Joma. This is very long. This is everything we have here. Everything, all the code we have here is compiled like into this. See the bytecode. This is everything we have here is. There are people who can decode this. There are people who can like go through these numbers and alphabets, everything here, and bring out this Yeah, I actually like there was a time I started learning. I wanted to be jack of all trades. I started learning, watching tutorials on this upcode. People that write off. They can go through this thing now and then bring out this contract from this bytecode you're seeing. So this is what this is compiled into, and this runs on the AVM.
Like decrypting this bytecode like this.
Yeah, there are people that can decrypt this thing.
Oh, that's mad.
Yeah, those people like I think they learn off. They scram it off. So this is the bytecode of this smart contract, and here is the ABI. I don't think you need this now, but just this is the ABI to this smart contract. We just put in. Let me just take the notes because the question. So like I was saying, compiled to bytecode that runs on the EVM. I just showed you the bytecode of our smart contract, and it's practically typed. Variables type must be sorry guys, explicitly defined. As I just showed you, you must state what type of data type you want to use, variable types you are using at all times. You cannot just come and tell us you want um number to be zero. What is the type of number? Is it integer? Is it unsigned integer? What is it? You must specify it. And then it supports inheritance. You can import libraries from other contracts and use them in your contracts. So Ethereum virtual machine, the EVM, which we're talking about, the EVM, the Ethereum virtual machine is the Turing complete. Let me just go to the explanation, the deep explanation. Okay, the core content. Yes. Thank you. Yeah. Okay. The EVM is a Turing complete, meaning it can perform any computation that a traditional computer can perform. And the EVM is just like traditional computer. The computer, you can carry out any task a computer can perform if you like we give you the resources. This allows for complex logic and algorithms to be implemented within smart contracts, including loops, conditional statements, and recursive functions. That is, the EVM can perform every task the computer can perform if it has enough data, enough resources, just like the conventional computer you have, like your laptop and the rest. And then it is stack-based architecture. The EVM uses a stack-based execution model. It has 1024 element stack for operands. Operations pop values from the stack, perform computation, and push the results back to you. And this simple execution model makes formal verification easier while reducing security risk. Like I said, Ethereum has the best security among all chains. And the memory model, EVM has three distinct areas for data storage. It has the stack, temporary working memory, which I just talked about, then the volatile linear memory space that exists only during contract execution. Like when you are signing the contract, this is when this memory exists. When the storage, the system key value store, where contract state is maintained between calls, and this one is the most expensive one. So the bytecode, I just showed you the bytecode of our extension. When a Solidity contract is compiled, it produces EVM bytecodes, a series of hexadecimal. I showed you hexadecimal means that's both numbers and alphabets. I showed you what that is. Hexadecimal opcodes and operands. Each opcode represents its specific operations. Like I say, there are people who can look at that and code it and bring out exactly what is in our smart contract. Arithmetic operands, the logic operations, the stack manipulations. Somebody has a question? Okay.
I don't have a question, but I have something to say. Sir, please, we are going into this smart contract news, so please, can you, like, maybe make even if it's a little documentary on the call functions we are to master in our like we have to have in our finger thumbs so that we can so that it can be easier for us when we like dive into fully.
Sorry, call function. I don't understand call function.
Like the core functions we are to know, like we are to master. Just like
Call
let me
function,
say
functionality. Okay, so
that we are to know.
we let me explain something. Solidity is let's say solidity is the foundation of a tree space. Okay, solidity um is a pace setter, like it's a how should I put it? Solidity is the introductory part of a blockchain. So by the time you move to probably Cairo or Rust, I don't think not like I'm trying to downgrade Solidity or any way or something. But when you start writing Cairo or Rust, I don't think you might want to come back to Solidity. Me personally, after learning Solidity, August last week, I don't think I've written anything in Solidity. I've always been um either Cairo, though I'm not that good with Cairo yet, but all my projects are depends on Cairo. If you on Rust, I don't like Rust yet. But you just have to understand Solidity to go deep, to dive into blockchain. There is no particular platform you need to understand. You need to like understand more than the rest. If you want to understand Solidity, try to understand everything. Understand how
Okay.
everything work, all the variables work, and then you
Okay,
move on.
so,
Yeah.
so are you trying to say that you're not running much of that Ethereum virtual machine? Because according to Ethereum, they say it is more of like Solidity on Ethereum virtual machine. Then Cairo and others are for other functions in the blockchain, that kind of thing.
Yeah, Solidity is for Ethereum and few other chains. Cairo is for only one chain for now. Cairo is for only Stacknet. You know Stacknet? You guys know Stacknet?
Yeah.
Okay, Cairo is for Stacknet. For now, only Stacknet use Cairo. And then Rust, you can use Rust for vast majority of questions. For now, you can use Rust for backend. You can use Rust for smart contracts to learn Rust. You can use Rust for mainly apart from smart contracts. You can use Rust to do other things, and it's very very powerful. But Solidity is purely for Ethereum. So far, I don't have because the reason why I don't write much of Solidity probably because I don't have any Solidity um, projects on at hand. Though there's one where I was just introduced to, who is not like going far with it, and I'm still trying to convince them to move that project to Darknet, probably because of the current I don't know how to put it. You guys know of only dust because of the grants and all that. So I'm trying to convince them to move it to Stacknet. The reason why I do more of Cairo is because of all my projects are on Stacknet. So if you can understand, you will more like you can focus more on Solidity if you want your projects to be on Ethereum or other chains that adopt Ethereum Solidity. If you want to understand Solidity, like okay, you just want to know everything about it, it's fine. It's fine. You can learn more Solidity, but then there's nothing to know and nothing to not know. You want to know, just like make sure you understand everything about Solidity. Solidity is very it's a layer one chain. It's a very good security. One of the best, if not the best, it's one of the best chain with the best security out there. While Stacknet is the chain with the cheapest, has the cheapest rate of transactions, and it's faster than Solidity. Stacknet is layer 2, and I believe the fastest is Solana, right? Fastest is Solana, and then the cheapest is Cairo, Stacknet, and then the one with the most security is Ethereum. It's Solidity. So most people want to learn Solidity because of Ethereum because of the security, and most people are going for Pyro probably because of Starknet cheap rate of transactions, and some other people are going for other. There are plenty other languages. There's Golang, there's Rust. You learn Rust. Mm. Personally, I'm not interested in most other languages. I'm only interested in Pyro and probably Rust, and then Solidity. I learned Solidity because I needed to like venture into Web3. Solidity is anywhere you want to go learn Web3. The first chain they teach you Solidity, usher you into the blockchain, and then we move to teach you other languages. Yeah, like Junkie, you have a question?
Yeah, so basically now, if someone wants to implement anything cybersecurity related into Web3, that means you need to have the knowledge on Solidity, right? Is it?
Not
Yeah,
into Web3. Depending on the like into Web3, for example, the chain where, for example, you want to integrate cybersecurity into your project, right? Web3 project. Or
exactly.
that depends on where the chain you built your project. It might not be Solidity. It can be Cairo. So you need to understand Cairo very well. It can be Stellar. There's Stellar. Use Rust. You need to understand Rust very well. So when I say security in this Solidity, I don't mean security like cybersecurity. I mean security in the blockchain, where hackers cannot hack into your contract like project and steal your money in your contract. I don't mean like other cyber security, but I believe you can integrate cyber security into Web3 projects. So for you to do that, you need to understand the language you use to write or the chain you use to write the chain that has your project. Can be Ethereum, can be Starknet, can be blockchain. Sorry, what's it called? The most expensive this thing.
But for a novice who is diving into Web3, right, is advisable. Someone should understand Solidity first before going into other languages, right?
Yes, that's what I understand. Because everywhere you go to learn Web3 today, the first listing language they teach is Solidity before they move into any other language. So you must try to understand Solidity to understand every other language. If you understand Solidity, I believe to understand other languages will not give you issue. But and if you understand Cairo, and then you will not find it too difficult to understand Rust because they have the same syntaxes and the rest. But first, you need to like understand Solidity. Like somebody was raising their hands, right? Okay. I believe my time is almost up. 7 minutes. So any other question? I was explaining this thing to the people that joined late. So we have the EVM has a deterministic nature. So it has is what like determinism is crucial for blockchain consensus. All nodes must reach the same state. What I mean by deterministic is what you give is what you get based on the input you give is same as the output you get. Is this understanding? So can you guys hear me?
Yes, can hear you.
Okay. I don't know my explanation. I'm trying to go back to where this is from. Okay, determinism is crucial for blockchain consensus. All nodes must reach the same state when executing transaction. Every VM operation is precisely defined to produce identical results across all implementations. Random number generation isn't truly random, but derived from the blockchain data. Timestamps are taken from block headers, ensuring all nodes use the same value. Execution is isolated from non-deterministic inputs like floating point annotations. So and you don't want to ask question about gas is nothing, right? So gas system mechanism. Gas system serves multiple purposes: economic security, prevent spam and denial of service attacks. Prevent spam is like people by using like people spamming other people, uh, like abusing the use of um, smart contracts and stuff like that. And then resource allocation, efficiently distribute computational resources. That's one of the uses of the gas system. And then mechanism of the gas system. And then halting problem solution, resolve the Turing completeness issue by limiting computation. And this is how the gas works. Each operation has a fixed gas cost based on computational complexity. More complex operation cost more gas. Example, store cost 20,000 plus gas, add cost just 3. For example, if you see this our smart contract here, you see the amount for this this getter function here is very, very small compared to what we are seeing in the constructor here. You see, this is about 20,000 plus. This is about 20,000.
So it's about 272,230.
You see, this is a complex, like I said, this is a complex what should we call it? As a complex operation, so it costs more gas than the other data function. And gas is paid upfront. Any unused gas is refunded. So if a transaction runs out of gas, changes are reverted, but the used gas cannot be returned. You cannot get it back. So the EVM execution context, when a contract executes, it has access to the call data. I told you guys what call data is. I showed you guys this is the call data. Any input, anything you put inside this parenthesis in a function, anything within this parenthesis in a function is the call data. So when a transaction executes, it has access to that call data. Sorry. That access to the call data, the caller address, that's the address of the sender, and the value. We are playing around with that contract and I was adding some values. That if to have access to that value, then the contract code, the byte code, the one I showed you guys earlier, and the block information, the timestamp, block number, and difficulty. You see, everything is here in this. Everything I'm talking about is here. You come here, you see, have access to. Here our last is the address of the sender, the caller, the person that called the function, and then this is the contract address, right? Yeah, I think so. And then the gas cost. Which okay, this is the getter function because so limited gas, and then this is the input, right? The output, and then we have the call data. This is the call data. Sorry, the value. This is the value. So anytime any transact anytime any EVM contract executes, to have access to all this timestamp, the core value, and the rest. And then cross-contract communication. Contracts can interact with other contracts if those contracts are like external or public. If they are private, you cannot communicate with them, you cannot interact with them. You can call their data, delegate the call, static call. You can like different types of calls to external contracts. Only the contracts must be external for you to interact with them. I showed you how to declare external and internal functions. We'll do more of that tomorrow. Internal and external variables and functions. We'll do more of that tomorrow when we start discussing the data types, variable types, and the rest. Then we create mechanisms to deploy new contracts dynamically. These interactions form the basis for compatibility in the Ethereum DeFi ecosystem. Like I said, you guys can read more about all this. I shared the link with you guys. It's already 12, and I think I'll wrap up. So before then, for those of you that joined late, this is smart contract lifecycle. Ethereum smart contract lifecycle. Sorry, Solidity smart. Yeah, it's something. Solidity smart contract lifecycle. Let me zoom out so you can see it in full. So you guys see it. For those that joined late. So first, you write the code, and then you compile to the EVM, write code, and then you deploy your transaction. By deploying, you are creating a transaction by deploying the contract, you pay gas fee, and then the contract is created on the blockchain. The contract is stored with a unique address. Every contract you deploy to the blockchain has a unique address, just like the wallet address, and then you can interact to the block with that contract, with functions of that contract via transactions. Every interactions you do every time you call any setter function, any state changing function, you are signing the transactions. So you pay that fee to execute any transactions. You only pay gas fee if the functions are state changing functions. If they are read-only functions, you don't pay gas fee. There's no gas fee. But if the functions you are calling in the smart contract changes the state of the smart contract, and then the transaction is wired, and you have to pay gas fee. If there's no gas fee, you cannot call those functions if you don't have gas fee. So I don't know if, for those of you that joined it, I believe you understand now. Hey, step junkie. I think he's the very one I'm explaining this into. So any question before I in this class, please? Can I give you guys assignment? Hello.
Yes, you can get.
Okay. So I want you guys to write a simple smart contract, a counter smart contract. It's very simple. Counter. You know, that's one of the projects we write anytime we're learning a new language. When I was learning JavaScript, that was the first assignment I was given, to write a counter app, an app that counts. So you can write a counter smart contract, just like this, just like the one here, but a bit different. Be a counter smart contract. You can name it contract, counter contract, and then you declare a variable unit count, set it to 0, or you don't really need constructor for that, unless you want you want to declare a modifier that I will say only the owner of the contract can change the state of the count. I don't know, maybe I should I don't want to write it for you guys. So I want you guys to write a simple counter contract for me. Okay? Just try. You can do it. Just play around. You can do it. The
Okay,
first
count,
question.
not counter contract.
You don't understand counter contract?
I want to know whether I want to be sure of what I heard.
Yeah, counter contract. Counter. Okay, let me tell you. You declare a variable count. You can use unit. You just use unit 256 count. And then you create a function to increase. You create another function to decrease. And you create a data function to get the current count. When you click on the increase function, the count should increase. When you click on the decrease, the count should decrease. It's very simple. When you click on the getter function, it will give you the current value of count. You don't need a constructor unless you want to like go ahead and like create a modifier for only for only owner to increase or decrease counts. You can then use the modifier. You can use a constructor and then modifier. If not, you don't need that. Just a simple counter contract that increase the number, decrease the number, and then give the value of the number. You guys can do that. It's very simple. Any question? All right, since there's no question, I think we can end this class here now. Have a nice day. Okay, I'll stop presenting now.
Okay, now announcement for us today.